Hi everyone, my name is Mateo Lopez, a student of the Salesian Politécnica University. And in this case, I am going to show you how I developed a Jupyter notebook that shows how to implement a simulation of a car wash business. In this notebook, we have to consider the following features. The Carwash allow to specify how many simulation cycles should be executed, and it will indicate how many units of time the simulation will last. And you will receive the number of vehicles that will be generated at the beginning according to roulette rounds. But we have to consider the following variables for the development of the simulation model. First, we have four types of vehicles that can be washed. We have cars, buses, vans, and dump trucks. Each car have a washing time. In this case, we have 5 for cars, 17 units of time for the buses, 11 for vans, and 23 for dump trucks. And each type of vehicle have a transfer time from the arrival to the washing machine. Cars have 2, buses have 5, vans 3, and dump trucks have 8 units of time. Also, we have a probability that machine will be damaged. This probability is 17%. Each time that vehicle is going to be washed, a round roulette must be executed, and if it falls below to the probability value, the machine is not, it means that the machine is damaged, and it takes 19 units of time to become functional again. So, if the machine is damaged, it means that the vehicle have to go to the waiting place again and taking again the count of transfer time. So we have the level of soap for all the resources machines for all the machines, and if it is less 40%, and the washing takes 5 units of time to recharge to the initial capacity. And to finish, we have the probability of arrival of each vehicle. We have 37% for cars, 20 for buses, 33 for vans, and 10 for the dump trucks. So after that, I'm going to talk you about the solution of this problem of this simulation. To begin, we have to import three important libraries we have Simpy, NumPy random, and Matplotlib. After import these libraries, how can I show you in this cell? We have to define some constant that we are going to use in the simulation. First, we have the maximum number of vehicles that the laundry or the car wash can receive, the total of washing machines that the laundry has, the time that each vehicle takes to wash, the interval of the vehicles arrive, the initial amounts of soap, and we have to consider that we have only one soap container for all machines, and the initial capacity is 200. The simulation time, the repair time for the damaged machines. We have the types of vehicles. We have cars, vans, buses, and dump trucks. The probability of each type of vehicle when them arrive, We have 37 for cars, we have 33 for vans, and we have 20 for buses and 10 for dump trucks. And we have some variables that we are going to use on the executing of this simulation. So we have to define a laundry class of a car wash class that contains the different operations and functions that it can perform. Each method have the explanation in the comments that I'm going to tell you to explain you. First, we have to define the car wash or the laundry class of the or laundry class. We define this way. After that, we have to initialize the variables that represent the laundry components, and some process is initialization process. We give the execution environment as a variable. How you can see here, we define an environment variable. We have to create the resource that represents all the three machines. And we have the environment that we define here and the number of machines that we define here. We have three machines. Now we have to create a resource that represents the sub tank or the sub container. So we have to use the Simpy library and the container method that receive the environment, the quantity of initial capacity, initial quantity of swap that is charged in the container, and the maximum capacity of the container. Next, we have to initialize the monitoring of the tank. In this case, we have to use the process method of the environment that executes a method that represents the monitoring of the sub tank. We have to send the environment as a variable, and this is the method that monitoring the swap container. As you can see here, we have to use an infinite booklet, and if the tank has a quantity of swap less than the minimum allowed that we defined here in the constants, a call is made to the tank filled method. So we ask here for the level of swap that is present in the tanks in the container, that is 18 because it represents the 40% of 200 number of the 200. The 200 where we are here. So we just print a message that says that the container is going to be full, and we have to start a process on the environment that is fill the sub container. We have to send the environment and this container. This takes 15 units of time to fill the tank. After we define a repairing method when the machines be damaged. Well, here we start the repairing of the machines. We have to set a timeout for the environment. In this case, we have the time of repairing. When the repairing ends, we show that a message that says that the machine is ready to be functional again, and we print the time or the timestamp of this event. But as we said in this line, the cars have to be moved again to the start line with the same turn to be attended immediately. So we have to ask for the time to move that cars depending of the vehicle type. So we ask for the times, and after that we take a timeout to represent that arriving time. So after that we define the wash function, the wash simulation. So the machines have, as we said in the features they'll consider in the simulation, the machines have a probability of be damaged. That is 17%. So we have to generate a random number from 0 to 100 that represents the probability of this damage. Can success. We ask that the probability is below to the minimum probability constant, and if it is true, the environment have to execute the reparation method, and we have to send the kind of vehicle and the number of vehicles that have to wait for be washed. So after this method execute, we have to ask about the state and the vehicle begin to be washed. We execute the washing simulation with each time to be washed depending of each vehicle type, and we take a timeout depending of this simulation time. I forgot to mention that each vehicle takes a number of quantity of soap that is used to wash each kind of vehicle. We have 30 units for cars, 70 for vans, 80 for 84 buses, and 100 for dump trucks. And just fun, we simulate the percentage of dirt removed of each vehicle. And so we show the message, and we have to add the number of vehicles that are washed at the same time. So we ask here for the vehicle the kind of vehicle. We ask here that some other vehicle have finished to finish it it washes, and we plus one to the mouth, or we just put one to the mouth. We have to make the same process for each kind of vehicle, as you can see here. And to finish the simulation of the washes of the car, we just print some message to the user. After build the car wash simulation class, we have to define the simulation method. So in this case, we receive the environment, the number of machines, the time for all the simulation, and the interval to the vehicles arrive. So we create 5 initial vehicles arriving to the laundry. In this case, we have the probability for each class, that is 57, 53, 20, and 10 for each vehicle, as you can see here. The range of probability we are defining in the first part of the simulation, as you see in these constants. So we generate a random number that is in the middle of 0 and 101. So we just initialize a variable in 0, and we ask if the random number generated is inside the range of the cars, or the vans, or the buses, or the dump trucks. And we change the state of this variable to 0, 1, 2, or 3, depending of each vehicle. So we execute the environment process that simulate the vehicle arriving, and we send the environment, the kind of vehicle, and some ID as you can hear, and the laundry, that is the component that represents all the car wash business. After generate 5 initial cars, we have to execute a while loop to continue generating some other cars on the depending of the intervals that are going to be generated randomly. So the process begins when a vehicle arrives to the laundry. So this method has been created to represent that event. So we can use the simulation clock, or we have to use this method to indicate when the vehicle arrives with the last name as parameter. We specify that we are going to use a resource, that is the machine, that represents the washing machine, as I said here. So when we request a machine, we use one of the 3 that we have, and we define waiting time in 0, but we ask for the kind of the car that we receive. So we make a split with this line, and we ask that this split is equal to the first kind of vehicle, and we ask the same thing for all the vehicles that we have to the simulation. After that, we have to make a timeout that represents the arriving time. And after that, we print a message that says that the transportation is going to initialize. After that, we just represent with another message to the user that the vehicle has arrived to the car wash. After that, we have to begin the washing process. We send the name of the car. With this method, we can represent that the swap container is under the limit, the permitted limit from the machines. So we define the function that receives the environment of the laundry, and we have to make a timeout that represents the filling time of the tank of container. After that, we print that the filling that the filling has finished, and we have to obtain the amount of swap that is going to fill the container. And after that, we have to put that amount that the tank needs to be filled, and we put this amount. So when all the process finish, we have to plot, we have to draw all the simulations that we executed in these lines. In this case, we executed 5 cycles of washing process. So we define the function that asks for all the dictionaries that contains all the histories of each kind of vehicles that are necessary to plot the lines or the points that represent how many cars, how many vans, how many buses, how many dump trucks were washed in each cycle. And we show the results of the current cycle. We delete all the history components inside the dictionary to plot the next cycle, and we remove all the components of the list created to begin the next cycle plotting. And that's all. As you can see here, we just execute the simulation process after structuring all the process of the simulation. As you can see here, we execute 5 cycles, and in these 5 cycles are represented in these plots. As you can see here, in this case, in the 7 units of time, 2 cars were washed In this case, the green line represents the bands that were washed. In this case, we have one in the 21 unit of time, or another one in the 35 times, 4 in the 44 yes. Another band was washed, and in the on the 47 units of time, and bus were washed. As you can see here, here is present all the message that the user just used to evaluate the simulation. And if you can see here, and machine had a problem, and it have to be repaired. In this case, another process. In this case, another machine was damaged. What we have here, and car number 4 begins the transportation process, and it arrives to the laundry in the 9th unit of time. So as we can see here, the car number 4 finished the process of washing. What we have here, we in this case, we can see that the machines have to fill again the container in the 30 unit of time, and as we can see here, the container finished to be filled on the 40 unit of time. And we can see here the results. As we can see, we just have 2 cars that were washed, and we can see here that only one bus was washed, because we had here a problem that no allows that other cars can be washed. So because of that, we just have one bus washed here. In other cycle, we have these results: one car here, one van here, one bus here, one van here, and one bus here. In this case, we have 2 vans, 2 cars, one bus. We have 1 car, 1 bus, one van, and 1 bus again. If we execute all the simulations again, we have another result. Just give me a moment. Yes, here we have another result, because all the processes is executed by using random variables. We have 2 vans, 1 car, and two dump trucks. One car, one dump truck, one van, one bus, and one car. One car. Let me see. One car, two vans, another car, another car, and one dump truck. And that's all. If this is all the process that have to be executed to simulate car wash business. So thanks for your attention. See you later.